I would like to welcome you. Thank you for joining me today. As we kind of take a deep dive into this topic, ChatGPT and generative AI has been sort of on everybody's mind. So before I dive in, I'll just provide a brief introduction for those of you who don't know me. So I'm Rudy. I studied AI and machine learning. Originally came out of academia in 2011. My PhD work was focused on probabilistic generative models. It did not involve deep learning, but it was generative nature. So it's kind of close enough, I'd say. So after graduating in 2011, I joined the business world, and I've been advising businesses ever since. And now, seeing how much hype there is around this topic, I thought it would be appropriate to kind of provide some clarity around that. All right. So, with that being said, let's dive in. I'm going to switch here to presentation mode and just get going. So, my objective today will be to, in a sense, I will first provide brief overview of large language models. Among the audience, from what I could tell, we have data science AI leaders, we have business leaders, students. So there's kind of a pretty nice mix of different backgrounds. So I will provide a background on large language models, even if some of you might be familiar with it. One of the main themes of this presentation today will be knowledge representation. So we will dive into how large language models are capturing knowledge. And then most importantly, we'll get into what kinds of options businesses have in applying large language models. And also, if given what's happening in the field right now, what should be businesses doing to prepare what's coming. Beyond that, we'll touch upon open source versus closed source tools, the cost and risk associated with large language models, and that will kind of be it. So we'll start off with some examples on generative AI. And there's been a lot that has happened. I'll start out with image generation. You might wonder why. Well, a lot of these image generation models are also tied to language. So there is a relationship. And I just want to touch upon the amount of progress that has happened in this field. So if you take a look at something like image generation, this sequence of images kind of illustrates the progress that has happened over the past year. So we have this old lady that looks kind of grainy and difficult to recognize in March of 2020. And then in 23, you can kind of see a huge difference. And that's just within 1 year. So that's one example. Within image manipulation, there's been a lot of work. And again, a lot of this is tied to language. Like Adobe introduced a feature where you could tell it what to do with an image, and it will remove things, objects from the image, or infuse them. So there are various very interesting image manipulation tools. This drag again allows you to take dots on an image and move them around, and it kind of adapts the image. So so there's some very interesting things that are happening within this generative AI, and it's something that's applicable across various domains. One particular company that has implemented generative AI already in their product is AutoCAD. So they have what they call generative design, where basically they use generative AI to generate different variants of components. And this is complicated because it might involve materials, it might involve various aspects of, this is not just the language. So this is yet another example of generative AI. and it's used in real life. So yeah, let's see here. One example that we have here at Reliancy that we've worked on is product called AutoCAD Rabbit, which is a product that is used for creating, well, architects use it to create drawings of structures. And so this product, kind of like PowerPoint or Excel, it has the ability to create macros that are code based and that then generate structures. So here we found an opportunity to utilize large language models to basically describe a structure and let a large language model generate the code that would then create an initial structure that an architect could start working on. So like these types of applications are really appropriate because it's kind of like writing a blog where you start out with a outline, and then as a professional you can hone it and you can improve it further. Now, ChatGPT itself, there's various use cases out there that people are reporting on. In particular, and I don't need to tell anybody what ChatGPT is because so many people are using it. It's kind of out there. But if you think in terms of use cases for businesses, customer support would be a big one where you would be using chatbots anyways. Provide conversation summaries. And then on the content design side, things like help editing, blogs, like assistant in writing, product descriptions, marketing emails, and personalization. On the information retrieval side, it would be things like search, interpretation, and basically conversational interfaces to retrieve information. And then lastly, coding assistance would be another example. Anybody that knows how to code and has tried out ChatGPT knows that it's producing fairly decent code. So you could give it English instructions and it will generate, for the most part, code that works very well. And as a matter of fact, a very popular site called Stack Overflow, which is used for looking up code, has experienced a dip in traffic as a result of ChatGPT because developers are finding these generative tools to be more convenient in getting what they need. So those are just some examples of ChatGPT. I mean, most of you are familiar with it. I just wanted to give from a few of these business use cases before we delve into that further. But really, if you think about ChatGPT, what it has done is that it has lowered the bar for using AI. So it hasn't really introduced new capabilities, if you will. A lot of these things like summarizing text, translating language, even question answer systems, they were there before. But where before you might need like 3 or 4 experts and several weeks of time to get a system together, now anybody, even people that don't really know AI, could just ask in plain English and they get something that works. And so, yeah, that has changed the game quite a bit. And the other thing that is done is that it's kind of brought all this information out there, to be at your fingertips. It's kind of like the whole world is a library and you're just one step away from getting to the information. And that's quite powerful. And also has made AI mainstream. There's like TV shows that talk about this. And so as we go out and we talk to businesses, what we find is a frequently question that comes up is, okay, so you tried out ChatGPT. We liked it. We found that it does some great things. Is there a way that we could apply this to our own data? It would be really nice if you could do that. Now, there are startups that are experiencing pressures in that regard because this is now a really hot topic and everybody wants to incorporate that into their product in some way. And some try to do that in a forced manner, but that's another side to it. And like specifically people that are providing user interfaces that are thinking, well, this seems to be like the best user interface ever. Like if you're able to talk to your system, like wouldn't that be great if every user interface was like that? Like if we had, for let's say our dashboarding that we use right now, if our stakeholders in the business could just ask questions and they could get the answers back, wouldn't that be awesome? So that's really kind of the angle, or the questions that we tend to get about applying large language models to business. And so that's kind of what we want to dissect a little bit further. So which ways are there to apply it, and like what kinds of use cases are appropriate for it, and like specifically how to address some of these things that may not be so easy to address currently. So all right, this is just kind of a long-winded intro. In this section here, I want to kind of briefly introduce large language models and talk about how to make them useful. So now there's a lot of talk about large language models, and you'll maybe hear the term foundational models. And people tend to associate that mostly with ChatGPT because that's what they've tried. And I'm talking about folks that are not in the field. So what exactly are large language models? A large language model is basically a model that will take a sequence of words, a sentence, and it will predict the next word in that sentence. So here we have to boldly go where no, and then the next most likely word would be man. And this large language model would have picked that up from a lot of text that it would have looked at out there on the internet. So that's basically the essence of it. And one thing that's important to note is that these types of models have been around for a long time, for several years. So what has OpenAI done? What has changed that suddenly there's all this attention and they seem to be so great? And so it's kind of important to realize that if you just trained a model on a whole bunch of text like this, it by itself will not produce the kind of capabilities that you see in ChatGPT. So it may just sort of go on and generate plausible text, but that may not constitute an answer to a question. It may just sort of, like if I start talking like Shakespeare, or like it might continue that in the same style, but it may not come back to me with answers if I ask it a question necessarily. So that's kind of one important thing to note. So if that's the case, how do you go from something like this to something that is like ChatGPT? Well, a starting point would be that you need to create training data, and the training data is basically in the form of prompt response pairs. So in this case, you see there's a question and there's an answer. Who is Captain Kirk? He's the captain of the Enterprise. And then why is Spock? Why are Spock's ears pointy? So I'm pointing this out is that if you're a business and you're thinking about applying large language models, what that means is if you want to apply it to your own data, you'll need training data, and the training data will be in form of these prompt response pairs, and you'll need a lot of them. So we're talking, potentially thousands. So the way this works is you take the original foundational model, which was trained on huge amounts of text and is really expensive to train, millions and millions of dollars for the OpenAI models. And so what you do is you take that and then you continue to train it, you fine tune it on these sort of prompt response pairs. And really the state of the art in this right now isn't just using prompt response pairs. Instead, OpenAI is looking at using an entire sequence of questions to kind of simulate this thread of thought, if you will, where like it's not just a one question, but really more of a conversation that they are training the model on. So what I found is when they start training the model with these kinds of prompt response pairs, then suddenly it starts becoming a lot more useful. And this effort of training it and nudging the model towards, providing responses is what they call alignment. Let's move on. So what OpenAI does is basically they use human labelers, or people, sit down and they create these prompt and response pairs, and also, and obviously they're collecting all this data when you're using ChatGPT for free, so they have lots of data. And what they do is they use contractors which will look at the output of the model and then rank the responses based on whether they believe, how good they are, good or bad. And so this ranking, they realize that they can't scale that to millions and millions of people. So instead, they build a model that can do this quality ranking, and this is called reinforcement learning, where basically they train the model using this other model that assesses the quality of the responses, as in good or bad, a ranking. And so that kind of goes on like that, and it helps the model improve. Right now, it's not quite clear whether this reinforcement learning step is really completely necessary. There is some work. So what we've seen before, just the prompt response pairs, this is called supervised learning. There's some work that indicates that maybe the supervised learning alone might be enough, and that that is questioning whether the reinforcement learning is necessary. So let's move on. So beyond, we've now talked about the basic model that needs to be trained on a lot of text. We talked about training data, which you would need to basically tune the model to your own, so if I'm a business and I'm interested in tuning it to my own data, I would need those prompt response pairs. And then the third opportunity to affect a model is in the prompt that goes in. And most of you by now know that prompt engineering has become a thing. And the reason it has become a thing is that these models are kind of sensitive to the inputs that they get. So depending on how I pose the question, who is Captain Kirk, I may or may not get the correct answer. And so, in order to get high quality responses, you kind of have to start learning how to interact with the model. And that's what the prompt engineers do. Now, there's also an alternate way of doing this, which is kind of based on AI itself. So think of it like building an added model that will infuse additional parameters, if you will, in addition to your prompt. It's like augmenting your prompt so that the responses become better. So that's what they call prompt tuning. And there's some results that indicate if you use prompt tuning, you can improve the results of your model. So I'm just emphasizing this to kind of make it clear that if I'm interested in applying this to my business, I have kind of two different options. One is the prompt tuning, where I can affect things, or actually three different options. Prompt tuning is one, the supervised training is one, and the reinforcement learning is one. So there's three different places where I can tune things. So step 4 in making large language models useful is, well, we've talked about tuning and all of that, but really one thing that is sort of come to light is that these models tend to get better as the number of parameters increases. So and that has skyrocketed. GPT-4 is around 1 trillion parameters. That's enormous. And so that's one thing that matters, and the amount of nudging into the right direction also matters. Nudging meaning fine-tuning. But there's also the realization that utility of this added size kind of diminishes at some point. So, like making these models even bigger is not necessarily getting a return on investment. So this is just kind of a very generic introduction to these for those of you that might not know the internal workings. And now we're going to get a little bit deeper into this and think about, so if we're interested in fusing business knowledge with large language models, it's really important to understand knowledge by itself. Like, how is knowledge encoded in large language models, and how do we encode business knowledge, before we can even think about fusing the two, right? So let's think about large language models for a moment. We've talked already about what the model is, kind of what it produces. I just want to briefly kind of cover how it does that internally, without going into any math or any technical details. So basically, consider a sentence like this that is a really question: who is the King of England? The way this model works is it will basically, for every word, it will try to relate that word to every other word in the sentence. And it will do that within multiple layers. It does this for 69 layers deep. So you can think of this like a derived contextual representation where, like here, think of this whole sentence as something that you could represent numerically. And here you're trying to get a representation for king in terms of all the other words. And you're doing this over and over again. And so what this does is it's trying to really capture the context of words, how they're being used. And it does a really good job at that. And so the output of the model after these 96 layers is basically probabilities over all of the words. And it's like a probability distribution which indicates which word is the next most likely word. So you take that probability distribution and you sample the next word. So let's say the word is 1. And so now you would take your window. So in this case, we had a window size of 6 words, and you shift the window. So you remove the word who and you add the word 1, and then you go through this process again and you generate the next word. And that's really how this works. It just keeps shifting this window and generating the next word. So when you're interacting with ChatGPT, it is really, just generating one word at a time. And the other thing to note here is this window size that you see. That window size is 8,000 in length. So that's how many words you put into that context. So that's kind of internally how that works without going into any of the technical details. What does that mean for the knowledge that it's capturing? Well, what it means is that it does really well in capturing the context in which words are being used. So this whole idea of looking at a sentence and trying to represent words numerically in some fashion is not new. There have been models that try to do this. Like there was a model that was introduced in 2013 called Word2Vec. And from those old days, like there was one thing that people realized is if you looked at the word representation, that the word, the encodings of the individual words, you could find that there's some very interesting things that happen. Like a queen would be represented in a two-dimensional space as an opposite direction vector from the word king, which was kind of like, if you think about it, the language, like this Word2Vec model, we're not going to go into the details of it, but it doesn't know anything about what a queen or a king is, but yet it was able to figure out that these are kind of opposing concepts. And the way this was possible is because if you look at language and you look at how queen is used and how king is used, and you look at the surrounding words, you kind of get a sense that they're used in different ways, and you could infer things about words that way. And so this was 2013. Now people are talking about ChatGPT as if it is the next thing that's kind of going to, basically destroy all of civilization. But all it really is a more sophisticated model, where this old model didn't really take into account even the order of the words. The GPT model is actually taking into account the precise positions of every word. So it will look at, like the previous 3 words and the 3 words that come after that, and it's not only looking at that once, it's looking at it in 96 layers. So the point being is that these models are really great at extracting contextual meaning. And so one example would be if you're looking at words, like 2 words like parking lot and talking a lot. Some of the older models might not be able to distinguish between lot and lot, whereas GPT would be able to do that. And so think about, like this is just a very small example. Think about if you're providing this kind of context within 8,000 words. Like that's a lot of relationships to maintain, and that's why the model is so large. But it also kind of gives you an idea for why and how the knowledge gets captured in terms of like the contextual meanings, and it can do that at very different levels of granularity, if you will. So yeah, getting back to the example, if you had something like this, a question of who is the King of England, this might produce an output, something like one might ask. So one might ask might be something that it picked up in a book, or like some paragraph out there. And if you look at this, like you would not be very satisfied in terms of what it's giving you. But this is just to illustrate what a non-tuned large language model would give you. So if I just took the model and I went out and I trained it on a bunch of textbooks, it would just generate whatever the next most likely sentence is. But while it's doing that, it is trying to understand, but contextually capture the meaning of these words and how they're used. So it may not know what a king is, but it constructs a representation of king based on the context in which it is being used. It's kind of like describing a king without really knowing what in terms of the circumstances in which it is being mentioned, king is being mentioned, without really knowing what a king is. But there is a model that's being built, and this is one of the questions out there that is being put out even by leaders within the field. Is this kind of a model kept maintaining a model of the world? Is it really understanding things? How is ChatGPT able to do things that it's able to do? That's kind of at the core of this question, and I'm trying to give you sort of a hint as to how you could explain what it's doing. And so the first realization is that it is capturing the contextual meaning of words really well. Moving on. So now, when we say we're going to use prompt response pairs and we continue to train the model, what that does, or what it means, is we're going to take, think of this initial path, think of it like a path, like the prompt response pair, where you have who is the King of England, and then you get one might ask. That's kind of like a generation path. When I try to tune the model, so when I come now with my business data, what I'm really doing is I'm trying to nudge the model to produce a different response. So in my training data, there might be a response that goes something like, the King of England is Charles. So now this response might be something that was actually already there in somewhere in this text out there on the internet, but it might just not have been the most likely next sentence. So when I fine-tune the model, I'm nudging it to make this the most likely next sentence. And so what I'm doing with that is I'm actually infusing additional knowledge. Because if you think about it, we talked about contextual knowledge. By looking just at language and nothing else, it can figure out kind of what king means in terms of the surrounding words and how it's being used. But now I'm also giving it, like questions and answers. It's kind of like a if then kind of a thing, and I'm actively infusing additional knowledge into the model that way. So I'm nudging it. One important thing here to note is when you're not, giving the prompt response pairs, you really don't have any guarantees that the model, once it's done training, will provide that exact same response. It will get nudged, but maybe it will not get nudged all the way to where you want it. And when you're training a neural network, usually, you don't want to train it in a way where it will be 100% right on your training data, because that's called overfitting, and that may not be something that you want. So that's just kind of to emphasize, like this is a toy example, but we're talking here applying this to businesses. So if you had your own business data, that's something to keep in mind. You're nudging it to incorporate the response, and you're giving it some of your business information. But at the end of the day, you don't have any guarantees that what it produces will actually be your business knowledge. So this question could be something like, what type of filter should I use for my refrigerator? And the response could be, the training response could be based off of, if you're a manufacturer of refrigerators, the exact model that should be used. But the problem is, if I do that training, I'm not guaranteed that the model will reproduce that response. Meaning, if I then use this, in a client-facing application, it might be giving me information about a completely different model, or it might just make things up based on what it thinks is plausible. So that's one thing to keep in mind. Moving on. Now, one thing that comes up a lot is the question of, so wait a second, when you use ChatGPT, this sounds like you're talking to a human, and it's able to answer things that even people that work in the field were surprised that it was able to answer. When they were playing around with it, it's like, oh, interesting. So how is that possible? Like, is it like there is this one developer at Google that was claiming their system was sentient, and this is part of what's making people kind of scared about this. Oh, like maybe this is going to be sort of the Terminator type of intelligence that will take over the world. So I'm going to take a very simple example to illustrate, to show you how this kind of reasoning could happen and how it could produce answers that it may have never seen before. So let's say, we trained the model and we gave it that prompt response pair about the king, and now we ask about who is the Prince of England. So let's assume that this is a sentence or a question it has never seen like this in its training data. But it does have in its training data Prince William somewhere mentioned in some fashion. So I mentioned earlier, we have an enormous model which is able to capture contextual relationships that goes like over 96 levels deep. So the way the kind of reasoning is, works internally is it knows it can pick up the relationship between king and prince, and if it sees Charles and William somewhere in its training data, then it may be able to infer that king is to prince as Charles is to William. And that's kind of how that inference can go, because it's really great at capturing these contextual relationships and sort of creating embeddings that represent them, like internal representation that represent these relationships. And so with that, you might very well get a response that says something like the Prince of England is William. And this is just a stupid example. I mean, there's more than one prince, but this is just to give you an example of how this contextual information that it maintains internally can actually be leveraged by the model to produce responses by basically aligning it. Because before, what you did with your prompt response is you kind of related King and Charles in a more direct fashion. You put more emphasis on it, and indirectly, as you're doing that, because of the relationship between Charles and William and King and Prince, you might indirectly be also emphasizing the relationship between Prince and William. And so just an example of questions that you might get answers to that were not ever seen. Now, all right, so maybe up until now you have thought, okay, most of this, if you're in the field, is familiar to me in some fashion. When are you going to get to the really interesting stuff? So let's get to that. There is a paper that came out in February of 22. I don't know, may have not received a whole lot of attention. It's called Locating and Editing Factual Associations in GPT. So what they did in this work is they took a GPT model and they used methods based on causal inference to basically relate the predictions of certain facts to activations within a neural network. It's kind of like saying, okay, let's look at a certain fact and let's try to understand where things are firing in the neural network. I think one of the examples that we're using is this in this picture here. The Space Needle is is in downtown Seattle or something like that. So that was like a fact that they looked at, and then basically what they were able to do is they were able to come up with an approach that can identify the location of a fact in GPT, and then they came up with an approach that was able to modify that fact within the model. So the implication of this is if you're looking at models that have billions of trillions of parameters, the model is actually maintaining facts within those parameters. It's kind of, you can think of it almost like a knowledge base where those trillions of parameters or billions of parameters, they're not necessarily all used for the purposes of being able to talk, for natural language, like a human, to facilitate like a conversation that has a good flow to it and sounds like natural. No, so basically the implication here is that a lot of those parameters are actually used to capture knowledge, kind of like a knowledge base. So that's it's very interesting, and we'll get back to that later in this presentation. So as far as going back to the question of how are we capturing knowledge, the key takeaways from this are basically three. One, contextual knowledge is extracted from text that it observes on the web. So just how certain words are used in sentences, that already provides knowledge. And it helps you construct kind of an internal representation of words that embeds that context. So that's knowledge. Then the other piece of knowledge comes in from your questions and answers. And keep in mind, OpenAI was not successful until they started infusing that knowledge. And they call it alignment. And they say this is key. And yes, it is key because as you're doing that, you're really infusing a lot of knowledge. And this is no longer just and people are talking about this, and like there's these sort of two extremes. One side will claim, like this is like almost sentient and it will whatever, take over the world. And then there's the other side that claims, so this is just a language model. It, predicts the next word. Well, it's not just that. If you think about it, if you look at all the question, prompt response pairs that are being used, there's a lot of knowledge that is being dumped into it or infused into it. And then lastly, this whole kind of idea that this model serves like a knowledge base in essence is also a very interesting perspective. And this isn't surprising. If you talk to ChatGPT, a model like that, you find that has a lot of knowledge. It seems to be coming from somewhere. So those are the key takeaways in terms of knowledge representation. Moving on. So obviously the big topic here is applying large language models to business data. And the question here is, what is the most appropriate way of doing that? And so I want to walk you through some of some of the options and some of the implications that come with these options. So roughly speaking, there are 4 different ways in which you can incorporate business knowledge into the model. And like you covered some of how it's maintaining its knowledge, and knowing that is going to give you some I guess broadened understanding of what these things do when you try to infuse knowledge into the model. Depending on the business use case, various different things are appropriate. So the lowest hanging fruit, first of all, the 4 options are, one is providing the business data in terms of a prompt. One is fine-tuning the model using your own internal data. One is something called Retrieval Augmented Generation. We'll get into that in a moment and discuss what that is. And the last one has a question mark associated with it. It's I have in there fusion of knowledge graphs and large language models. This is not one that exists as an established method. Let's put it that way. But it's a really important one that we will get to in a few minutes. So moving on. So when it comes to prompt-based deployment, basically what that is you're going to look at your data, your business data. Let's say you have a document, and you put that document into the prompt, and then you ask a question regarding the document, and your large language model responds. So the nice thing about that, let's see here. So the nice thing about that is I don't have to tune the model. I could just literally go into ChatGPT, I dump a big document, and I ask a question. But if you go back to that perspective of GPT being kind of like a knowledge base, then you're not really modifying the weights of the model in this case. You're not infusing new facts. You're giving it the document and you're asking it to reason about that document based on what it already knows. So yeah, let's get back to this. So the benefit of doing this is that it's very inexpensive. It works well for generic tasks. So if you have tasks like text summarization, like generate some code for me, provide the sentiment for a comment for a customer, those types of things, they're kind of fairly generic language tasks, and so you could expect the language model to do fairly well in those tasks. The disadvantages of this approach is that you only have a limited window of text that you can give it. So ChatGPT accepts 8,000 parameter window size of 8,000. There is a version of 32,000, and that's kind of it. So 32,000 or 8,000, that's that's a lot of words, and actually those are tokens. Well, yeah, words. But if your knowledge in your business is really enormous, you may not be able to fit all the relevant context in that window. And the bigger issue here is you really don't have control over what the model is going to respond with. So it might pick up what you're interested in, but it might give you a completely different answer, and you have no control over that. It might work well in 70% of the time or 80% of the time, but you just don't know. It's prone to hallucinations. And in this particular case, if your business has very specific terminology, the model will not be aware of it because you have not fine-tuned the model. You're just giving it the prompt. And yeah, it might just not be something it's familiar with. So moving on. So the next thing that we talked about is fine-tuned deployment. So in this case, as we touched upon before, you would take your business data and you would generate training data out of it, a lot of prompt response pairs, and then you would continue training a model. There's been a lot of optimization that has been done by the open source community in regard to fine tuning. So this can be done fairly inexpensively now. It's not a matter of millions of dollars. So it could be done. And it's something that's worthwhile considering when you're dealing with a domain that has its own terminology, and when the amount of data that you have is too large to pass in a prompt. So this way you have an opportunity to give the model a lot more information. And you end up with your custom model for yourself. So when would you want to fine-tune a model? Well, the benefit of it is it does incorporate business terminology. And I already mentioned these. You can incorporate more information, and it's tuned to provide business relevant responses. So when businesses come along and they ask us, okay, so how do we apply this to our own data? This tends to be sort of the very first thought. Oh, okay, maybe we can do it with fine-tuning, with prompting. Let's just fine-tune a model for our own data. And you're going to find that a lot of the cloud vendors out there are providing out of a packaged solution to do this for you, like NVIDIA, Microsoft. You just give it the prompt response pairs and it will generate a fine-tuned model for you. So this can be done fairly easily. But the issue is that the thing that the business leaders ask for is not really fully addressed by this, because you still don't have control over exactly what knowledge the model will pick up. So yeah, it will have, like if you go back to that perspective of GPT being kind of like a knowledge base, you're giving it a lot of business knowledge, but like what it produces, it's still kind of a black box to you. And you may still get a completely irrelevant answer when you ask about that. Going back to the example of asking for appropriate filter for my refrigerator, it may, if I'm a client and I'm interacting with a chatbot, I might still get, maybe it will do really well in the majority of the times, but I have no control that this is not going to give a very damaging answer where it will just give me something completely off the charts, or either make it up or just base it off of other knowledge that it may have picked up, even like a refrigerator model that it might have found in some documentation on the internet. Like, you have no way of telling it, don't use that. You all you can do is you can fine-tune it with your own business data and kind of hope and pray that it will pick that up and that it will use that when you ask for it. But yeah, that's kind of the challenge with this. And so one thing I wanted to mention here is, if you are contemplating to fine-tune your own models, there is a tool called H2O Wizard LM that will, given a set of prompt response pairs, it will basically use a large language model to create more training data for you. So the challenge is that, if you're a business and you want to apply this, a large language model to your own data, it's expensive to generate the training data. And so, these models are kind of data hungry. They want hundreds of thousands of data points, and maybe you can only generate a few thousand. So in practice, what a lot of them do is they'll take a smaller training set and they kind of blow it up. But this process of blowing it up may introduce errors. Like, it's not guaranteed. But I just wanted to share with you that, this would be one of the tools out there to use for people that want to fine-tune a model. So who would want to fine-tune a model, and what are the implications of that? So if you're fine-tuning a model and and there's also distinction here whether you're fine-tuning something from OpenAI, which is possible and it's out there on the web, or you're using an open source model. But one key distinction or one point of concern for clients is, are we going to be giving up our own data, and how much exposure do we have to potentially leaking places where it shouldn't be leaking. So if you fine tune an open source model, you don't give up your data. You own the models, but the models are going to be less powerful than what OpenAI has. They've just invested the most in terms of that alignment, or the prompt response pairs that are sort of manually labeled. They've invested the most in that, and that's the reason why one of the reasons why their model is the most performant across a variety of tasks. But if you go with the open source model, it gives you, you can nowadays, open source models are not too far off from the commercial models, and so you might be able to get a decent performance by doing that. So it looks like we're at 11:27, so I'm going to have to move things along faster here. So I will do that. Retrieval augmentation was the third one, as we mentioned. And this is basically like a pipeline for creating, basically serving documents to the model. And there's a very popular tool out there that is called LangChain that is used for this purpose. And basically what this is you start out with a question, what model should I use for my refrigerator? What filter model should I use? That query, utilizing sort of old-fashioned tools, gets converted into a vector, and using a search lookup, it will retrieve documents out of your company knowledge base that are relevant to that filter and that refrigerator, and then it will use those documents and serve them into the prompt for the model. And so that's what this is. Now the model itself could be fine-tuned, and the idea here is that you're really sort of automatically retrieving what's relevant and sort of populating these prompts that way. And yeah, this is it's called retrieval augmented generation, because rather than manually piecing together the prompt, you have sort of an automated way where you're first retrieving what's relevant, and then you ask the language model to respond. So this is helpful. So some of the cloud vendors provide capabilities like this, like NVIDIA provides it, where you can just use it, and it'll give you a response. So it has its benefits that you're getting the relevant, like you're trying to get the relevant context in place, but in doing that, you're kind of reducing the chance. Like this is the example here. I'm just going to skip through this because we're running out of time. The benefit of that is, you get an automated pipeline to create these prompts, and you might even pull in like a fine-tuned model, but you still don't have full control over the knowledge that is utilized in coming up with the response. Hallucinations are reduced, but they're not eliminated. So now, if we're talking about applying large language models to your business data, this is sort of currently the state of the art of what's available, if you will, this retrieval augmented generation. And like there are tools, there are pipelines out there that you could readily use, and this is something that you plug into PDF documents and other kinds of documents. And this does make sense, if you are retrieving documents. If and actually, this is something to be said about all of the methods we mentioned so far. If you're working in a scenario where you don't have to have exact responses, where some errors are acceptable, then all of these would make sense to use. But if you want to use your large language model on your business data and let's say expose it to a business stakeholder where errors are not acceptable, where hallucinations are not acceptable, then the key takeaway here is that none of the methods we've covered are able of doing that. And you've seen that like ChatGPT is being discussed a lot, but you're not really seeing business applications left and right. And this is the main reason for it, is we have these hallucinations and they're limiting the applicability of large language models. It's obviously they can drive a lot of value, but they can only drive value where you can handle those errors in some fashion and they're acceptable. But a lot of the business applications out there, especially client facing, it's not okay to hallucinate. It's not okay to make those kinds of mistakes. And there isn't really none of these approaches, the three that we have discussed up until now, have a knob to allow you to address that. And this is kind of where we get to the last one. And I think I'm going to go over time, maybe 5 minutes. I apologize. If you guys can't stick around, a recording will be available. Again, here I have the tools listed out that you would use for this retrieval augmented generation. The last part that I wanted to address is the most important one. So how do we deal with hallucinations? What are the next steps for large language models? The title of this webinar has been making large language models actionable for business. And so so far what I can tell you is most of what you will be able to read out there on the internet and available methods, that all comes with the assumption that the models are going to be hallucinating, and whatever use case you pick, you need to think of these models more as an assistant, and one where somebody will be reviewing that. And so this kind of brings us to the question of, okay, so if we're going to be fusing knowledge, the business knowledge, with the large language model knowledge, how do we then represent business knowledge? Obviously, so far we've talked about GPT, being in essence like a knowledge base. You're taking knowledge and you're throwing it in there, and the knowledge that you're throwing in there is not dependable. Like for facts that you know to be true or false, you're throwing them into a model that will then maybe make something true or false depending on how it was trained. And you're throwing them into a model that might have 1 trillion parameters that may not be very efficient at all. So the way to this is kind of an open question out there. I'm just going to talk about one option, and one that is currently very actively being researched as a candidate for fusing knowledge with large language models, and those are knowledge graphs. The issue of knowledge representation is a huge question in AI and has been for decades. How do we represent knowledge? And knowledge graphs have been part of that for many years. More recently, technology called native graph databases have been developed, and this is since 2008 or 9. Neo4j was the first database, and this sort of opened up this world to enterprises, to businesses. And so there are currently a lot of businesses which apply knowledge graphs internally. A knowledge graph basically is a way to represent business knowledge, where you have nodes in the knowledge graph that represent entities like customers, transactions, and whatnot, and then there's edges that represent relationships. And when you're building one of these knowledge graphs, you usually only focus on data that is relevant for insights. So you don't just take all your data and dump it into a knowledge graph. You're connecting the relevant dots. And so there are a number of businesses that have already undertaken this effort. A number of them have not. The benefits of these knowledge graphs, or they're called enterprise knowledge graphs in the business world, are that they're interpretable, they're editable, and they're efficient. So they can really be helpful in figuring out how to structure knowledge internally. And what companies are finding is that they're useful for generating insights, for like they're driving a lot of value. Even like the companies that have implemented this so far, they've not been doing it because of generative AI. They've been doing it because these knowledge graphs are adding value for basically enabling business intelligence and all sorts of AI applications, because you're piecing together the knowledge in a way that an AI model can leverage. So how does this come into play now? Thinking about, so there's a talk. Well, first of all, this comes back to the GPT model. There's the question of, okay, so if we kind of realize that it's capturing facts, I mentioned this already. The question that arises: do we really want to use that to capture facts? And like that's kind of the reason why we're not able to control that knowledge, and that's part of the problem in making this applicable to business, because like I want to make sure that if the client is asking about my filter for the refrigerator, is going to get the right answer. And maybe the type of filter changes over time. You want to be in a position where you have control over the knowledge. And then like, is it really the wisest thing to take that knowledge of your business and just dump it into the model and then blindly trust the model that it will retrieve the right facts? And it is failing in doing that. And the other aspect of this is that it's not just that you're fusing in that knowledge, is that you have 1 trillion parameters that have to fire every time you're asking for something, and that's a lot of overhead. So there's a pretty nice talk by a guy called Denny Radencic. He's the head of special projects at the Wikimedia Foundation. I've included the link to this YouTube recording of his talk, or post-conference recording, and it's about the future of knowledge graphs in a world of large language models. And he kind of goes into this, and it's kind of very interesting. And really, the question here would be: is there maybe a better way to think about large language models and the knowledge that is being maintained? That how about if we utilize knowledge graphs to store facts about our business, the things that we know, and we use the large language model for what it's great at, which is ability to talk fluently and to use natural language for reasoning. And so this is sort of a sort of a mutual benefit that happens here when you merge the two, because knowledge graphs don't have any native capabilities for natural language or natural language reasoning, and LLMs have the problem of hallucinations. So if like the whole question here is, what do you do with the knowledge? Do you internalize it all into the large language model, or do you externalize the knowledge and keep it elsewhere where it's editable for you and where you can manage it and control it? And so I'm emphasizing this isn't just some kind of an idea that I've taken out of thin air. This is a hot area of research right now, and probably the most promising direction of where and how hallucinations are going to be addressed in large language models, and a promising direction for businesses, because this is a way in which you get control over your business knowledge, and you have a way of maintaining it. So I don't have a whole lot more. I apologize for going over time. Now, I mentioned this is a hot area of research, and I mentioned more about that in a moment. But one thing I want to emphasize is, if this is an approach that seems reasonable to you, then there is a simple way in which you could do this right now without going complicated. Which is, let's say you have your knowledge graph. You can utilize the large language model to simply tell it about your ontology, about the structure of your knowledge graph, and you ask the language model to retrieve the knowledge that you want. You know that the large language models are really great for code generation and for query generation, and so they actually can do a fairly good job if I just tell them, this is what I want, and then it generates the query into the knowledge graph. It retrieves the information, and you just ask it, oh, can you summarize this information for me? So that way, you are basically not depending on the knowledge of the large language model. You're not using it as a knowledge base. You're using your own knowledge base, but you're using the language model for your interactions with it, for translating language into code, and for some level of reasoning. Now, this is a very simplistic and also extreme example, but it illustrates to you how there is a knob that you can have here that allows you to control for hallucination, because here the model doesn't get the opportunity to hallucinate. The only way it could hallucinate is by making up queries which don't resolve. And so it's easier to put in guardrails here. It's not going to come back with, a model for your refrigerator filter and it belongs to another refrigerator, because it might come back with a different answer from your own knowledge graph, which you can then check by using additional code. The one sort of hidden piece of work here that I want to emphasize is in the second stage. When you are translating the language into the query, there's a sort of implied translation that has to happen here, which is translating into the business domain terminology. Because in your knowledge graph, you might be using knowledge terms that are not common knowledge. But the nice thing here is you could be constructing a knowledge graph specifically for the purposes of fusing it with a large language model. One thing that I'll say here is, what this comes back to is, if you're thinking about ChatGPT, we're here at a point where it has certain applicability, and it's limited by this hallucination issue. But you can think of this as a wave that's coming at you. And it's coming at you because there's so much value that has been shown. There's a lot of money being pumped into this. So it's not a matter of whether this will be addressed. It's just a matter of when. And so, if you're a business, short term, you can think of, okay, let's see what kind of use cases do I have where I can live with the hallucinations. But the long term, you need to be asking yourself, what do I need to do to be ready for my business knowledge to be fused with an AI model? And that is really boiling down to a question of really more of a data strategy. How do I organize data within my organization so that it is able to facilitate, the ability to maintain knowledge, to expose knowledge. And, the good news here is, if you emphasize this, it's not just a matter of generative AI, it will help you become a more data-driven organization. So, that would be my big piece of advice here is, long-term, if you want to be ready for generative AI, you need to make sure you have a proper data strategy in place that will make sure that your knowledge is properly organized within your organization. Because this is where things are moving. And if you don't believe me, you can just Google it, or you could research it yourself. But this is an extremely active area of research. There's multiple publications out there on this. I've shared here a few for those of you that will get the slides. But basically, this first one is really interesting because it's kind of like provides a literature summary of the various work that was done, and they highlight that, okay, knowledge graphs have issues. They might have gaps in knowledge, and they don't have natural language understanding. And then the LLMs, they have the hallucination issue. When you bring them together, they both sort of complement each other. So there's work where knowledge graphs are being enhanced by large language models. Then there is work where large language models are being augmented by knowledge graph information. And then there's work where basically you're merging the two and creating a synergy. I just created referenced here two works that are relevant to this. One is the second one is being done by Amazon. Our graph-aware language model pre-training on large graph corpus can help multi-graph applications. So this gets really complicated in what they're trying to do with product recommendations and whatnot. But the point is, this is where, this is where the most active area of research that I'm seeing, and the most promising research as far as being able to infuse some control over what knowledge a large language model uses, because inherently it's built in a way to hallucinate, and the hallucinations are not necessarily always bad. Hallucinating means it can be creative. So there are use cases where this creativeness comes in as a good thing, like you're doing blog posts, you're doing creative work, it does that for you. Now, but if you have a business application that's critical in terms of responding with your business knowledge, then that creativity is shooting you in the foot, because you got all this, it's really awesome to be able to talk to it like you would to a human, but you're just not able to apply it to your own data. And your CEO might get really upset if he asks your dashboards for some insights and then the insights are made up. So this is kind of this is the big takeaway from this webinar. Let's see. I will skip over the remaining slides quickly. I've already gone way over time. Thank you to everybody that's stuck around. I know this was intended to be 1 hour. I'll just quickly mention open source community has done an immense progress. There is a leaderboard by startupdan.com where the performance of the commercial models like GPT are stacked against the open source models, so you can kind of track how, what kind of a performance gap there is. The original leaderboard comes from Hugging Face, and that only lists the open source models. And among the open source models, not all of them are free for commercial use, because they might have been trained on output from GPT. And GPT, OpenAI, prohibits the output to be used for commercial purposes. So in terms of costs, they've gone down significantly. So this is a non-issue for fine-tuning and even for serving. If you want to train your own model from scratch, that's really that's a different story, but it's not really necessary. The risks we've talked about, they can be addressed. Like depending, if you're willing to go the knowledge graph route. And as far as conclusion goes, I've already iterated these. The big takeaway is, if we're looking at what's out there right now, you have to take it with a grain of salt. You have to be really careful where you apply large language models. There's a definite path forward, and that path forward has to involve somehow an understanding of how knowledge is represented and how to fuse it. You might not believe in knowledge graphs, that's fine, but you could still have to address that issue. And it's very unlikely that it's going to be addressed within the latent space of the neural network, because that's a black box. You can't understand it, you can't modify it, you can't maintain it. So thank you very much to all of you for your time. I apologize for going so far over time. I will send out a survey to everybody. For those of you that fill it out, we'll also get these slides. I just ask for feedback. Let me know if this information was useful to you, or what else you might be interested in for kind of the next webinar. If you have any questions, feel free to reach out to me. Since I've gone so much over time, I will not be taking them now online, but feel free to send me a message. And if you wish to have a one-on-one conversation, I'm open to that as well. Thank you.